Later in the semester, we will see that there are multiple ways of expressing the concentration of a solution. However, the most useful way of expressing the concentration is molarity, which is defined as the number of moles of solute per liter of solution. The concentration of a solution is an intensive property, in that it remains the same regardless of the amount of solution we study. However, once we have a given amount of solution, the number of moles of solute within it remain exactly the same, and it can be calculated by multiplying the concentration and the volume. If we double the volume, we halve the concentration, and their product remains a constant. Conversely, if we evaporate the solvent and halve the volume, the concentration will double, and again, their product remains a constant. When we titrate an acid with a base, or a base with an acid, we know that the number of protons given will be equal to the number of protons accepted at the equivalence point in our titration. The strength of the acid and the base is not a factor. We need only concern ourselves with the number of moles of protons donated and accepted. We therefore need to know the concentrations of the acid and the base, as well as their volumes. But at the equivalence point in the titration, we know that the number of moles of each is the same, and we can equate the two. The end result is an equation where we can determine an unknown concentration if we know the concentration of one and the volumes of the acidic and basic solutions. The solution of known concentration is known as the standard. Remember that some acids can give multiple protons, and some bases can accept multiple protons. Merely take this into account when calculating the number of protons donated by the acid and those accepted by the base. Finally, precipitation reactions are useful to calculate concentrations of ions in solutions that are neither acids nor bases. We call this a gravimetric analysis. In a gravimetric analysis, ions are made to form a precipitate by introducing a species that will make it fall out of the solution. As we can see in the solubility rules, nothing forms a precipitate with a sodium cation, and therefore a gravimetric analysis will not work for sodium. However, with a silver cation, we know that anions such as chloride or bromide will form a stable solid that will fall out of the solution as a precipitate. Therefore, if we can dry off the precipitate and weigh its mass, we can figure out the number of moles of the precipitate, which in turn gives the number of moles of the silver cation originally in the solution. And if we know this, and the original volume of the solution, we can determine the original silver concentration in the solution.